Good morning, guys. Today we're going to look at solving radical equations and inequalities. So a radical equation can also be a rational exponent equation. Remember, those are interchangeable concepts. So to go through and solve, we've got a few steps. Start by isolating the radical or the rational exponent base. So in this case, our radical would be square root of x minus 3. So we want to get it by itself. And just use your normal equation solving rules. Move the terms that don't have your radical in it. That'd be your that'd be your 7. So subtract that over. So 2 square root of x minus 3 equals 4. Divide by the coefficient. So x minus 3 equals 2. Now, I'll tell you right now, that divide by the coefficient step is actually optional in this point. In this case, since we're dealing with a radical, because it's all exponents of multiplication, so you can be flexible in what order you do some of those steps in. I will divide by that as long as it gives me a neat, clean number. If I was going to be dividing, say this had been 7 divided by 2, it had been 7 halves, I don't know that I would have wanted to try to work with exponents off of a fraction. So it's kind of your call at that point. But, you know, just for general rule of thumb, you're going to move that coefficient of the radical before you actually get rid of the radical. So we've isolated the radical. The next move is raise both sides of the equation to the power of the index. This is a square root, so we eliminate that by squaring both sides of the function. So when we square, you're going to get x minus 3. 2 squared is 4. And then you finish solving like you always do. Isolate your variable. X is equal to 7. And we have to check for extraneous solutions. Remember, extraneous solutions are false answers. Answers that algebraically we have created, but they don't make sense in the context of the problem. So if I was to go back and plug in 7, 7 minus 3 is 4. Square root of 4 is a real number. So it's really going back, remembering you can't take the even root of a negative number. So we just want to plug this back in and make sure once we do all the arithmetic, once we evaluate what the radicand actually is, the portion underneath the square root or radical actually is, make sure that if this is an even index, then we do not have a negative radicand. If we did, we would just dump that answer. And if all the answers dumped, we would say there's no solution in this case. So we get x equals 7. Well, let's look at this as if it had not been square root, but instead had been a rational exponent. So if we went through plus 7 equals 11, and instead of it being square root, it was 1/2 power. Let's go through and look at it that way. So we're going to isolate the rational exponent base. I'm going to isolate the x minus 3. So again, move the 7. 2 times x minus 3 to the 1/2 equals 4. Again, optional at this point, but I'm going to divide by the 2. X minus 3 to the 1/2 equals 2. And I want to get rid of this exponent by raising both sides to what would it cancel out of 1/2. Well, what cancels out of 1/2? Well, we're going to multiply. Remember, power to a power, we're multiplying. So to cancel a number out by multiplication, you're multiplying it by its reciprocal. So we're just going to do the reciprocal of 1/2 on both sides. The same thing we did when we squared the square root. That's actually what causes the squaring of the square root to cancel out. So that cancels, leaves me x minus 3 equals 4. Add your 3, and we get x equals 7. And again, since we had an even denominator, even denominators are even roots, we've got to go back and check. 7 minus 3 is 4. 4 is non-negative, so we're allowed to do the even root of a non-negative. So x equals 7. Okay, give me a few minutes and I'll get some examples up here of radical and rational exponent equations, and I'll let you guys try them out. So here we have 4 examples. I want you to pause the video, take a few minutes, and try to solve each one of these. They each offer something a little bit different. So like I said, try these out, see how you do, and I will wait right here. Okay, hopefully you were able to get these 4 solutions. Let's see how you did. So first one's a standard radical equation. We're going to isolate the radical. So we're going to move our 5 over. So I get cube root of 7x minus 1 equals negative 2. Then we're going to raise both sides to the index. So I get 7x minus 1 equals negative 8. And then we go through and solve. Move my 1. So I get, we'll move this up here, 7x equals negative 7. Move my 7. So I get x equals negative 1. And with all radicals, we want to check. Typically it's only the even roots, but let's just get in the habit of checking all of them. 7 and negative 1 is negative 7, minus 1 is negative 8. Cube root of negative 8 is negative 2. 5 minus 2 is 3. That one checks out. Let's go to number 2. We have a rational exponent equation. So we're going to start by isolating the base. So we're going to move our 4 over. That's going to give us 2 times 3x plus 1 to the 2/3 equals 18. I'm going to move my 2 by dividing by it. That's going to give me 3x plus 1 to the 2/3 equals 9. We're going to raise both sides of the equation to the reciprocal. Reciprocal of 2/3 is 3/2, which 6 over 6 cancels. Let's move over here. We got 3x plus 1 equals 9 to the 3/2. We can go through and we can do this by in our head with mental math. Denominator of 2 is square root, so square root of 9 is 3, and then 3 cubed is 27. And there's something we have to remember when we put square root into the problem. Whenever this denominator of that rational exponent is even, we've got to remember that's an even root. We've got to plus or minus that. Okay, do not forget, if your denominator is even, that's an even root, we have to insert plus or minus. Very, very important that we remember to do that. Insert the plus or minus there. So we can just go through and solve like normal there. So 3x equals negative 1 plus or minus 27. Divide by 3. So x is going to be equal to negative 1 plus 27 over 3. So that's 26/3. And negative 1 minus 27 over 3, which is negative 28/3. So we get 2 solutions on this one. And let's just go through and check them. 26/3 times 7. Oh, sorry, wrong equation. Sorry. 26/3 times 3 is 26, plus 1 is 27. Cube root of 27 is 3. 3 squared is 9. 9 times 2 is 18. Minus 4 is 14. So 26/3 works. Negative 28/3. Let's see that one. Negative 28/3 times 3 is negative 28. Plus 1 is negative 27. Cube root of negative 27 is negative 3. Square that gives us positive 9. 9 times 2 is 18. Minus 4 is 14. So both of these solutions work out. So the little thing you need to pay close attention to on this one is obviously reciprocal your exponent. But since we have an even denominator after that we raised both sides to, we need to make sure that we put plus or minus on the simplified expression there. All right, let's clear some room and we'll work on these next 2 equations. So the one on number 3 up there, we notice that we have the square root of x plus 2 equals x. So we have variables in the equation, or inside the radical and outside the radical. Don't let that impact anything. We've got to dump this radical before we can do anything else. So I'll get rid of a square root by squaring both sides of the equation. So I'm going to square both sides. That's going to give me That'll cancel. X plus 2 equals x squared. Now we see we have this quadratic equation. So let's go through and check and see what's going on. Move the x, move the 2. So x squared minus x minus 2 equals 0. I believe this one will factor. X squared is x and x. Negative 2 is negative 2 and positive 1. Negative 2x plus 1x gives us the negative 1x. And we go through and set each factor equal to 0 and solve. So it's really just doing the same stuff we've been doing. X equals 2. X equals negative 1. And we just, there's just a variable on the outside of the radical now too. Go through, check your answers, looking for your extraneous solutions. So 2 plus 2 is 4. Square root of 4 is 2. So 2 equals 2. So we're good on that one. Okay, negative 1. Negative 1 plus 2 is 1. Square root of 1 is 1. But 1 does not equal negative 1. Because remember we said we put negative 1 in here for both x's. So this is negative 1 and this is negative 1. Well, when you do negative 1 on the left side, you get 1 for the whole left side. When you put negative 1 on the right side, it stays negative 1. So this is one that didn't work out. It was a false answer, it's an extraneous solution. So x equals 2 is our only solution. And it's all because we had this squared on both sides that after we squared it would have been equivalent, but there was no square in the original expression. So those even roots again are what's always going to cause you issues when you're dealing with those when you're looking for extraneous solutions. So really double check those. Let's look at number 4. Number 4 is very different because it has two different radicals in the equation. Hope y'all were able to get it, but we'll see. It has two different radicals in the equation, so that means we're going to do some special stuff. When we're solving, we isolate the radical. Well, there's two radicals. Just pick one of them to isolate. And it doesn't matter which one you pick. This one's pretty simple because when you isolate one by moving the other one to the other side, they end up both being isolated. So just get one radical on one side. You can only deal with one radical at a time, so just move the other one over. So we'll say 2x plus 1 equals fourth root of 3x plus 1. Now, I'll just get rid of the smaller one first, just because it's the one I'm looking at. It really makes no difference. So how do we get rid of a square root? We square it. So cancel that, you're left with 2x plus 1. What happens when you square a fourth root? Well, think about what's going on. Fourth root means 1/4 power. So when I square a 1/4 power, I get a 2/4 power, which just reduces to give me a 1/2 power. So the fourth root of 3x plus 1 squared actually is the square root of 3x plus 1. So that squaring of that fourth root, 2/4, just reduced to give me 1/2. So I end up with a square root. Now we still have a radical in the problem, so we just go through the process again. Isolate that radical. So how do I get this square root by itself, or square root gone? I'm going to square both sides again. Square both sides again. So on the right side, I get 3x plus 1. On the left side, I've got a binomial squared. And remember, we do not distribute that exponent because these are not multiplication. Those aren't factors. We're not multiplying 2x and 1. We're adding 2x and 1. So you've actually got to go through the hard math of doing 2x plus 1 times 2x plus 1. Well, as hard as the distributive property for a pair of binomials is. You get 4x squared plus 2x plus 1 equals 3x plus 1. Now we just have a regular old quadratic equation that we can go through and solve. So let's clear ourselves some room to solve this. So 4x squared, I'm going to subtract my 3x over. That's minus x. I'm going to subtract my 1 over. That's 0. So I get 4x squared minus x equals 0, which is easy to solve because we factor out the common factor of x, set each factor equal to 0, and isolate our variables. So we get 0 and 1/4. Let's go through a check real quick. 2 times 0 is 0, plus 1 is 1, square root of 1 is 1. Minus 3 times 0 is 0, fourth root of 1 is 1, 1 minus 1 is 0. That one checks out. Fourth root, 2 times 1/4 is a half, so we get square root of 3/2. Check this one, 3 times 1/4 is 3/4. 3/4 plus 1 is the root of, just went brain dead. Sorry. 3/4 plus 1 is 1 3/4. 1 3/4 is going to be 7/4. Now, does that one give us the same thing? Okay. Over 2 to the 2/4 is square root of 2. And we've got square root of 3 and fourth root of 7, which is not the same thing, as far as I can see. If that was fourth root of 9, then it would be, but we don't have that because we have, which is 3/4 plus 1, which is 7/4. Okay. Unless I'm missing something, these are not equivalent, so they're not going to equal 0. So that means 1/4 would also be extraneous. Double check that. I may have messed up something somewhere, because usually it's a little bit more obvious, like the last one was when we had the extraneous. But again, from what I can see, they are extraneous. Or this one is extraneous, and x equals 0 is our only real solution. Give me a second so we can look at radical inequalities. So I'll get that information up there and we'll get started on it. Now guys, let's look at solving radical inequalities. Now to solve radical inequalities, we're going to have to find critical points, just like we do when we're solving any of these large, whether it be polynomials or rational functions or now radical equations or logarithmic functions. We're going to have to find critical points. Now the critical points in a radical inequality come from the solving the equation like normal, and then you also have to look at your restrictions on the domain, because remember, an inequality solution is not a single value, it's an interval that contains a range of values. So we're going to have to find the restrictions of the domain, because we've got to figure out where are we even allowed to start looking for answers. Now we know the restrictions on the domain of a radical come from the radicand, and that's really only on the even roots. Even roots are the only ones that are limited on what we can plug in, because remember, you can't take the even root of a negative number. So anytime we get an even root, we're going to say that that radicand, the portion underneath the even root, is greater than or equal to 0, and that's going to give us our those are going to give us our critical points. From there, it's just like all the other inequality work we've done. We're going to test a value from each interval to determine which interval is the actual solution interval. So let's say we have this example right here. I'm going to do two things. First, I'm going to look at the radicand. That's the portion underneath the radical symbol. So square root is an even root. So I know that x plus 5 has to be greater than or equal to 0. Cannot be negative, so it has to be greater than or equal to 0 because I can't take square root of a negative. Let me tell you, subtract 5, so x is greater than or equal to negative 5. So it really tells me I'm not working negative infinity to positive infinity. I'm only working negative 5 to positive infinity, because it's everything greater than or equal to negative 5 are the only things that could possibly be in this solution set. Now let's go and solve the actual equation and see what our x has to be. So we go through, we're going to subtract 3. It's just and we treat it just like we do an equal sign. Don't worry about the inequality symbol. So I'm going to get 2 square root of x plus 5 equals 4. Divide by 2. So square root of x plus 5 equals 2. Square both sides. X plus 5 is equal to 4. And we subtract 5. So x is equal to -1. So this is my other critical point. -5 is one critical point, -1 is the other critical point. Now we go grab our number line. When I'm doing inequalities, or when I'm doing inequalities with radicals, this is one of the few times I won't just look at the graph, because the graphs on these can get very hairy and very confusing, especially when you throw a lot of different types of radicals into one equation or one inequality. So I'll pretty much stick with the number line and just testing a point from each interval to be able to solve these. So let's set up our number line. I'm still going to do it negative infinity to positive infinity. You'll eventually get to where you're comfortable enough with these. You'll be able to use that stipulation right there to kind of dump a portion of that. But just to keep it consistent with how we've been doing it, let's go negative infinity to positive infinity and put your critical points on there. -5 and -1 are your critical points. And we're just going to test points from each interval. So to the left of -5 is -6. Between -5 and -1, you pick whatever you want. Say you want -2. To the right of -1 is the one we all like, which is 0. And then we just plug back in. We have 2 times the square root of -6 plus 5 plus 3. And we want to know, is that less than or equal to 7? That's all we want to know. Is that less than or equal to 7? Well, -6 plus 5 is -1. And none of the rest of it even matters because -1 is imaginary, so we know that that one can't work. And that just goes back to confirm what we found with our domain restriction. X has to be greater than or equal to -5 because we tried this number to the left and it gave us an imaginary solution. So again, you'll get comfortable with recognizing that. Tells you to go ahead and dump that left interval. Now let's test the next interval, this -2 here. So 2 times the square root of -2 plus 5 plus 3. And we want to know, is that less than or equal to 7? So -2 plus 5, that's going to be 3. Square root of 3 is a little bit less than 2. 2 times a little bit less than 2 should give us a little bit less than 4. A little bit less than 4 plus 3 will be a little bit less than 7. This is about 1.8-ish. So this is 2 times that would be about 3.6 or so. And plus 3 is going to put us at approximately 6.6. You know, really, really rough estimates there. But we can see that's less than 7, so that interval happens to work. But, you know, punch these numbers in the calculator when you're dealing with all this radical stuff to get a little bit more exact stuff so you know what you've got. But I'm just kind of estimating off the top of my head right now. Let's try the 0 right here. So 2 times the square root of 0 plus 5 plus 3. Is that less than or equal to 7? Yeah, that one was. Check mark. 0, so square root of 5 is a little bit more than 4, you know, 2 in a pinch. 2 times that, what's this? This is probably about 2.3 or so. 2 times that's going to put us around 4.6 plus 3. Put us around 7.6, I think, thereabouts. And that is not less than or equal to 7, so we don't use that interval. So our solution interval is between -5 and -1. It's or equal to, so we get to bracket those. So we would write -5, -1 for the solution to that radical inequality. Again, with all this radical stuff, use the calculator to calculate those a little more precisely. Again, I'm just kind of estimating those off the top of my head, but that is the correct solution interval. Give me a second and I'll get a few more examples up here for you guys to try. Okay guys, we've got a few examples up here. I want you to pause the video, take a few minutes, and try to work these 3 inequalities out, and I'll wait right here. All right, hopefully you were able to get solutions to each of these. Let's check your work and see how you did. So in the first one we look at it, it is an even root, so we've got to find our domain restriction first. So I'm going to take 3 minus x, say that that must be greater than or equal to 0. So however you want to do it, we can add the x over. 3 has to be greater than or equal to x, or we could write that x less than or equal to 3. Now we're going to solve the equation and determine what the solution is, what the critical point is from solving. So I'm going to start by squaring both sides. That's going to give me 3 minus x equals, remember just treat it like an equal sign because we'll test to determine the inequality portion, equals 4, and then move your 3, negative x equals 1, move your negative 1, x is equal to 1, and those are our critical points. So we test from negative infinity to positive infinity. We're going to look at negative 1 and positive 3. Pick a point from each interval. So if we picked 0 obviously for the middle one, and we go negative 2, positive 4. Pick whatever you want in those intervals. So if I test negative 2, 3 minus negative 2, square root of that, is that less than 2? Well, that's square root of 5. Is square root of 5 less than the square root of 2? No, because square root of 4 is 2. So this is a little bit bigger than 2. So that interval doesn't work. Let's try between negative 1 and 3. So test 0 out. So square root of 3 minus 0, is that less than 2? Well, is the square root of 3 less than 2? Yeah, because the square root of 4 is 2. So square root of 3 has got to be less than 2. So that interval works. Let's try 4. We're going to do square root of 3 minus 4. Is that less than 2? Well, that's square root of negative 1, which stops everything, and we know that doesn't work. And that fits with our domain restriction. It says all x's have to be less than or equal to 3. So we knew that it had to be one of these two intervals anyways. So we find that it's this interval in the middle, it's not or equal to, so we'll just use brackets on 1 and 3. So the solution ends up being, let's find the best place to write that, from negative 1 to positive 3. Now let's look at the next one. We have an odd root, so I don't have to worry about domain restrictions. There are no restrictions on the domain of odd roots. So we just go straight into solving it. And we'll start by moving my 3. So I get 4 cube root of 2x plus 17. We're just going to treat it like an equal sign, equals 12. Divide by 4. So I've got cube root of 2x plus 17 equals 3. To get rid of a cube root, we cube both sides. 2x plus 17 equals 27. Then we just isolate our variable. Move the 17. 2x equals, what's that, 10? Move the 2. X equals 5. So we just have the one critical point to test in this one. So let's actually clear some space over here to do that in. So if we have one critical point from negative infinity to positive infinity, that's at, looks like positive 5. So we'll say 0 over here on the right. We can, 0 over on the left. We'll just go 6 over on the right. You can pick whatever you want. And test them out. 4 on the cube root of 2 times 0 plus 17 minus 3 greater than 9. That's just going to give us cube root of 17. Cube root of 17 is, let's see, cube root of 8 is 2. Cube root of 27 is 3. So it's somewhere between 2 and 3. So about 2.5. 4 times about 2.5 is going to be around 10. 10 minus 3 is about 7. Is 7 approximately 7 greater than 9? No, it's not. So that interval shouldn't work. Let's try this interval over here. So if we go 4 times the cube root of 2 times 5 plus 17 minus 3, is that greater than 9? All my 7s look like greater than signs. Minus 3, greater than 9. Okay, so as we go through this one, 10 plus 7, 10 plus 7 is 27. Oh, we don't want 5, we want 6. Of course that was going to work out. 2 times 6 is 12. 12 plus 17 is square root of 29, which is cube root of 29 is a little bit bigger than 3. 4 times a little bit bigger than 3 is a little bit more than 12. A little bit more than 12 minus a little bit more than 3. That's probably about 9.2 approximately. That is greater than 9. That one checks. So we'll take that interval. And again, since it's not or equal to, we won't use the brackets. And that's the answer, from 5 to positive infinity. All right, let's move to the last example down here. Oh, sorry, I messed this one up, guys. This was supposed to be the square root of 32. So y'all probably got some very, very interesting answers from doing it that way. Let's try it with the square root of 32 because something special happened here I wanted y'all to see. So we go through, we're going to start by finding the interval for the domain errors, the restrictions on the domain. So I'm going to take x squared minus 4 has to be greater than or equal to 0. So we just go through and solve. Add 4, x squared has to be greater than or equal to 4. So x, take your square root. X is going to be greater than positive 2 and less than or equal to negative 2. Okay? Or less than or equal to negative 2. If you don't remember all that stuff, treat it like an equal sign, and when we test the intervals, it'll work out. But what this is telling me is I should only get answers from the right side of 2 and the left side of negative 2. Remember, that's plus or minus because we put the square root onto the problem. Again, if you don't remember the directions about the inequalities there, just treat it as 2 and negative 2, and when we test our critical points, or test the intervals of the critical points, it'll all wash out anyways. So we have the domain restrictions, which is right here. Let's go through and solve using square root of 32. Again, I apologize for putting that up there incorrectly. So I've got x squared minus 4 equals 32. We're going to square both sides. And that leaves me x squared minus 4 equals 32. Add your 4. So x squared is going to be equal to 36. Square root both sides and we get plus or minus 6. So I end up with 4 critical points on this particular problem. So we test from negative infinity to positive infinity. I'm going to look at negative 6, negative 2, positive 6. And in each interval, we could go negative 7, negative whatever you want, negative 3, I guess will work. We'll go 0 here. We'll go positive 3 and positive 7. And we'll just test them out. So I've got square root of negative 7 squared minus 4. And we want to know, is that greater than square root of 32? Well, this one's pretty straightforward. That's 49 minus 4 is 45. Is 45 greater than 32? Yes, so that interval checks out. Then we go with this one right here, trying the negative 3. So negative 3, myself some room to test these points. Square root of negative 3 squared minus 4. Is that greater than square root of 32? So that's 9. Minus 4 is 5. Is square root of 5 greater than square root of 32? No, it's not. So that interval doesn't work. Check the 0 interval. So square root of 0 squared minus 4 greater than square root of 32, which is square root of negative 4. And we got the square root of a negative, so that tells us to dump that interval also, which goes back to what we found with our domain restrictions. Stay to the right of 2 and the left of -2. So we're going to be left of -2, right of +2. Again, if you don't recognize and remember that stuff, when you test your points, it all washes out anyways. Okay, we can go through and actually just make a couple of adjustments. Let's make this +3 squared, which is still +9. +5, that one still doesn't work. Okay, +7, let's put it right here. +7 squared is 49, so that interval does work. So our intervals actually end up being the outside ones this time. And since we're or equal to, we've got to bracket our values, our non-infinity values. So the solution for this inequality is -infinity to -6, along with +6 to +infinity. So that's the solution. Remember your interval notation. We have multiple intervals. We combine them with that union symbol. Okay, so that's it for solving radical equations, rational exponent equations, and radical inequalities. Yeah, that's it. I'll see you in class tomorrow, guys.